Alright, welcome back to Learning with Merit. Today we're going to talk about lists and two-dimensional lists and working with for loops. So here I have a two-dimensional list, and we can think of that as a list of lists. So here's the list. The little yellow square brackets indicate our outer list, and that list is filled with lists of its own. So there we have 1, 2, 3, 4 lists inside of that list. Now, typically what we'll do is we'll think of this as rows and columns. So I've got this formatted in my code so that it looks like rows and columns. So here we have 1, 2, 3, 4 rows. So the length of list 2D is equal to 4 because there are 4 rows. And then we have 1, 2, 3, 4, 5, 6 columns. So the length of each row, so length list 2D row, is equal to 6. And you'll notice that the length of list 2D is 4, but the last row index is 3. And the length of list 2D row is 6, but the last index for the columns is 5. And that's exactly what we would expect. Remember, we start at 0, okay, for our indexes. So if I wanted to know the index of any given letter here, like Q, for example, I'm going to come over here and I'm say, okay, 0, 1, 2, so it's at 2, 0, 1, 2, 3, 4, so it's at 2, 4. X would be at 3, 5. Okay. A would be at 0, 0. B would be at 0, 1. C at 0, 2. I would be at 1, 2. And hopefully you're starting to get the idea. One trick that you can use that can make it easier for you, especially if you're confused, is just count where it's at. So this would be 1, 2, 3, and this would be 1, 2, 3, 4, 5, and we're going to subtract 1 from both of those. So I'd subtract 1 from 3, that gives me 2, and 1 from 5, that gives me 4, and there you go. 2, 4 is our indexes. So that's a real quick way to do it in your head, especially if you don't have it all nice and pretty like this for you. So remember, we have 4 rows, we have 6 columns here. And of course, each one of these is called an element, and each element in a two-dimensional list has 2 indexes. Okay, 2 index numbers associated with it. First, which row it's in, and second, which column it's in. And like I said, A would be at 0, 0. So let's talk now about how we go forward through these lists and actually get something out of them, or print them out to the screen, or use them in our code. Right? We want to keep a few things in mind. One, to access an element, right? To access an element, we need to use the list name and then provide a row and column index in order to access it. Then when we use the range function in our for loops, we want to remember that we have a start, a stop, and a step. And the stop is not included. So it goes all the way up to the stop but does not include it. So if I'm going from 1 to 10, it actually goes from 1 to 9. And so I would need to use 11 as my stop if I wanted it to go to 10. If I'm going down from 10 to 1, if I put a 1 here, it's only going to go to the number 2. So I want to put a 0 instead, and that would give me all the way to the number 1. So now we need to talk about our nested for loops and how we do this. One, we're going to need one for loop. We're going to need one for loop for the outside. So we're going to say for row in range, like that. And then we're going to need an inner for loop. So this one's going to go through our rows. So it's going to go 0, 1, 2, 3 through our rows. And then for each row, we have 6 columns. So I need one to go through our columns. So we're going to say for column in range. Just like that. And then we're going to do underneath this, you'll notice we have indentation here. Okay. Then inside of this is where I'm going to do all the stuff I want it to do. Okay, so it's pretty simple. We have a simple nested for loop there. So here's our first one. Let's loop through the columns and rows forward and print out the indexes. Now we got a lot to break down here. So we have for row. Row is our index variable for rows in range. Now range tells us where to start, stop, and step. So we're going to start at 0. That's the 0 index. So we're going to start right here. Then the length of list 2D, is 4. But because we don't include our stop, it only goes up to the third number, so it goes 0 through 3. And that's what we want for our row indexes. And of course, we're going up every time. Then we have our columns. So I'm in the first row. Now let's go through the columns. So I have the 0, that's where I want to start at, that's good. And then length of list 2D row, so each row has a length, all right, and it is 6, but because we go all the way up to the number right before 6, that's 5, this works out for us, and then we're going up by 1, of course. So then we print out the indexes here, print row, comma, and column, because row and column are our indexes that we're using. They actually represent the numbers that go with these. And by printing out both numbers, we have one for every single spot in this two-dimensional list. So this would be 0, 0, this would be 3, 5, and every number in between. So if I hit play here, see it gives me a little bit of an error, and that's usually because I haven't saved it correctly. And there we go. So you'll see, top left-hand corner is 0, 0, that would be A. Bottom right-hand corner is 3, 5, that would be X. Okay, and then of course we have every single thing in between, okay, those two numbers. So then let's say that we wanted to print the elements. Only one thing's going to change, as it did with our one-dimensional lists. There's only one thing that is going to change. So here we go. Hopefully you noticed everything stayed the same except for this part right here. To get the elements, I need to tell it what list and then what row and what column index I want. And since I'm going through the whole thing, it's going to go all the way from 0, 0 down to 3, 5, and we should have everything from A to X just like it is up here, printed out exactly the same way, because I added this little print statement here to format the output. So if I hit run, there we go. Here's A in the upper left-hand corner, just like we have here, and here is X in the bottom right-hand corner, just like we have there. So this allows us to go forward through the rows and through the columns. What if I wanted to go backward through either or both? Right? Well, to go backward, I have to change a few things. Same basic setup, but we're looping backward through the rows and columns now. So we still have row and we still have column as our indexes. Our ranges change though. So now this time we want to go from the end of our rows. So we actually want to start here this time, on this row. We want to start on this, whoops, I don't want to do that. We want to start on this row. So I got to start at 3. So how do I do that? Well, I get the length. The length is 4. That's what I did right there. I got the length is 4. And then I subtract 1. That'll give me the number 3. So now I'm starting at this row. Perfect. Then I want to go down to 0. But in order to get to 0, I have to use -1 so that it includes the number 0 whenever it gets there. And then, because I'm going down, I need -1. Same thing in our columns. I want to start at the last column. Well, the length of our columns are 6. Our last column index is 0. So this is the column I want to start with. So here's my start, and I need the length of list 2D row. Well, the length of the row is 6. 6 minus 1 is 5. So now we're starting here. That's perfect. That's what we want. We want to go down to 0. So we come all the way down to here. So we need -1. Okay, so that it includes 0. Remember, that's important. We have to use -1 so it includes 0. And then we use -1 all the way at the end so that we're going down. Okay, because we don't want to add 1. If we add 1 to 5, we go to 6, then we get a list index out of range error. And that's bad for us. Because then we have to go back and fix something. All right, and then of course we're printing out the indexes this time. So you'll see it just says print row, comma, column. This is just for formatting. This is just for formatting. Okay, the actual functionality is all up here. Let's hit run. Actually, let's hit save first, and then let's hit run. Let's see why it's having an issue here. All right, there we go. So you see, we've got 3, 5, and we've got 0, 0. So 3, 5 is right there. That should be X, and 0, 0 is right there. That should be A. So you see, very interestingly, that it should be totally reversed because we went backward through both. So now, if we want to do elements, because we just did indexes, we want to do elements, we're going to, as per usual, change one simple little thing. I'm going to copy this, Here we go. Paste it right there. So let's see what changed. Well, we're still starting at the last index for the rows. We're still starting at the last index for the columns. We're still ending at 0, and going down. So everything there is the same. The only thing that changed was right here where I say list 2D. So I'm asking for this list, and then for the spot at row, spot at column. And so it's going to start at 3.5 and bring back X. And then it's going to go to 3.4 and it's going to bring back W. And then 3.3, it's going to bring back V. And it's going to have that whole thing, basically this, but reversed down here. So if I save that correctly and I hit run, let's see what happens. And there we go. We have X up in the upper left-hand corner at 3.5, and we have A at 0, all the way down at the right-hand corner now. So we've totally reversed the thing. And that's a lot easier than going through and having to retype all of that out, especially if you have to do it with a much, much larger list. So now that we figured out how to do that, we went forward and we went backward. Let's talk about the shorthand for this. Now there is no shorthand for going backward, but because so often programmers have found that we go forward through these lists, we have a little shorthand, and it's called a for each loop. A for each loop works a little bit different. You'll notice that it's much different than the range stuff that we've been using. So this time it says for row in list 2D. Now this is going to change what row represents. Row no longer represents an index. It actually represents the entire row. So when I say for row in list 2D, I'm representing each row, and that's what's stored in the row variable as we go through. Same thing for column. Column literally represents each element as we go through. Okay, and that's for each row. So instead of saying print list 2D row column to use the indexes, this time I just say print column. And what that will do is it will print out each element in each row throughout the entire list. And this only works whenever you're trying to go forward through the list. There's not an easy way for us to go backwards doing this. And so this shorthand only works when you're trying to go forward. Okay? Only when you're trying to go forward. So let's clear our output that we have. Let's save this and hit run. And you'll see, look, it did the same thing that looping forward the other way did. Now, I'm going to caution you because you're going to want to do it the easy way. Everybody always wants to do it the easy and the quick way. And this is easier and quicker. 9 times out of 10, it's going to be easier and quicker when you're doing something simple. But lots of times you want more control on what you're doing, and so this is not going to be the best way to do it because you may find it doesn't work and you have to rewrite your code anyway. So speaking of which, let's try something a little bit different. That's how we use a for each loop to make it shorter. Let's try something that changes our values. So if I want to change the values in a two-dimensional list, okay, here I have my for row in range, and I can't use for row in list 2D and for column in row because then it's not easy for me to change the list. And so I actually need to use this range in order to do it. And what you'll notice is that I only provided the stopping values this time. And that's because range assumes start is 0 and step is 1. And since it already assumes that for me, there was no reason for me to write it out. So I just left them out of the range function. So now what we have down here is, this is just me changing everything to an X. So if I save that, you'll notice it doesn't do anything when I hit run. And if you're thinking, you know that's because it's not printing out anything. There is no output from this, and that's why I don't get any output. So if I want to see what this has done, I actually need to add something to print stuff out. Here's where that for each loop can come in real handy. It's quick, and it'll print out everything for me. So I just add this down here to do all the printing for me, and then I'll focus up here on doing all of this code. So let me come down here and add this. Prints out the list. Just like that. Okay, so now you won't see that but it's doing the printing out of the list for me. So I'm going to save and hit run. And you'll see now the list, everything has been changed to an X. Here's something else we could do. I could create a string called vowels. So I could say vowels like this. And we all know A, E, I, O, U. They are vowels. And of course, sometimes Y, but we're going to leave Y out. Okay, we're just going to use A, E, I, O, and U. And then down here, because I don't have to change anything, this does all the looping for me. This does all the looping. I don't have to change any of that. I'm just going to change this down here. I'm going to say if. And I'm going to check if, okay, I'm going to check if list2d, and then where I'm at, row, column, is, whoops, not equals, in vowels. This is a cool little thing you can do in Python. So what it does is it checks if the element, because that's what this gets, it checks if the element is in this string called vowels. So it checks for A, E, I, O, and U. And if it is, we can change it to something. So I can say list2d, and we change row, and we change column, okay, the thing at row column. So we could say we're going to get to A, and we'll find that A is in vowels. So list2d 0, 0, and we're going to change that. And I don't know, let's change it to something easy. Let's make it a dash. Oops. Let's make it a dash like this. And that way we know that that's where a vowel was. And I know this seems simple, but of course the point is that we learned how to do it because we're going to have more challenging problems in our lives. And this is a simple thing to think about. So if it's not in vowels, it just skips it. It just goes on. It doesn't do this code if it's not in vowels. Okay. So let's see what happens. Remember, I've got this code down here to print it. This isn't doing the printing. This is doing the printing. Okay, so I hit run here. And look, we replaced all of the vowels with the two little dashes. That's a pretty cool thing you can do. And then let's say that if it's not a vowel, we know that it's a consonant, right? So I'll just add an else in there, and we'll say list2d, thing at row, thing at column. And let's say, I don't know, let's make those a, let's make them a $sign, just for fun. Okay, so all the consonants are going to be $signs, all the vowels are going to be this double dash thing that we did. You know, play, and so we changed all of the consonants and all of the vowels, and so that's something interesting you might be able to do with this. But this is how we use a little if-else conditional statement to change something in our list as we're looping through it. So we loop through and we check everything, and this is much easier than going through by hand and doing it, especially when it's a very large list. So this is it for using two-dimensional lists and for loops, and I hope that you learned something about this, and I appreciate you listening.